This video, we're going to use the same properties that we use to expand logarithms to condense them. We're just going to go the other way. Anything with a positive coefficient, that coefficient is going to be the exponent in the numerator. Anything with a negative coefficient, that is going to be the exponent in the denominator. So for instance, on number 30, they both have a positive 1, which means they both have exponents of 1 in the numerator. With the multiplication, so this can be log base c of q times r. Number 31 is going to be log base b of m to the 5th divided by n. There's a negative 1, so there's an n to the 1st in the denominator. 32 is going to be log base c of 9 to the 4th is 81 times 81, 1,864, 116, 656. 6561 divided by 5 to the 5th is 625 times 5, 3725. 33 is log base a of q minus log base a of r plus 6 log base a of p. So this is going to be log, let's do what's inside the parentheses first, log base a of q divided by r plus 6 log base a of p. Change that to log base a of p to the 6th. The p to the 6th is in the numerator. They have the same base. P to the 6th q divided by r. So this is log base c of qr. This was log base b of m to the 5th over n. This was log base c of 6561 over 3725. This was log base a of p to the 6th q divided by r. Now we're on 34, 2 log base c of m minus 4/3 log base c of n plus 1/6 log base c of j minus 6 log base c of k is log base c of m to the 2nd times n to the negative 4/3 times j to the 1/6 times k to the negative 6th is log base c of m squared j to the 1/6 n to the 4/3 k to the 6th. That's sufficient. I don't think that I need to write any roots there. So yeah. If I wanted to look at this and say I wanted to make it all into a root, I could possibly write this as the 6th root of j and the cube root of n to the 4th. I could do that instead of those fractional exponents if you'd rather see that. M squared times the 6th root of j over cube root over k to the 6th, which is the cube root of n to the 4th. That would also be acceptable. 35 is 3 log base 6 of x plus 5 log base 6 of x minus 6. So that's going to be log base 6 of x to the 3rd times x minus 6 to the 5th. And there's no reason for me to expand that any more than that. Let's get rid of that multiplication symbol because it's assumed if I write my x to the 3rd there. Log base 6 of x to the 3rd times x minus 6 to the 5th. Three log base a of 2x plus 1 minus 2 log base a of 2x minus 1 plus 2. It's going to be log base a of 2x plus 1 to the 3rd divided by log divided by 2x minus 1 to the 2nd. And then this is going to be times 2. So that 2 is a log base a of a squared. So if I want to get that a squared inside of there, that's a log base a of a squared 2x plus 1 to the 3rd over 2x minus 1 to the 2nd. Log base a of a squared times 2x plus 1 to the 3rd over 2x minus 1 to the 2nd. Right. Now we have ln of x squared plus 3x minus 40 over x minus 1 minus ln of x squared plus 7x minus 8 over x plus 4 plus ln of x squared minus 10x plus 25. So I'm going to try and factor things and maybe do some expanding and see if there's some cancellation, some addition and subtraction of logs where things zero out before I try to get too far into condensing this. So this is going to be ln of, and in my numerator is going to be x plus 8 and x minus 5 over x minus 1. And this is ln of, and then this is x plus 8 x minus 1 over x plus 4. And this is ln of x minus 5 quantity squared. So this is ln of x plus 8 plus ln of x minus 5. minus ln of x minus 1 minus, because there's a minus on the outside, ln of x plus 8 minus ln of x minus 1 plus ln of x plus 4, because it's minus a negative, plus 2 ln of x minus 5. So that makes a 0, and that's one of these makes a 0. And I've got an ln of x minus 5 left. And I have a ln of x plus 4 minus 2 ln of x minus 1 plus ln of x minus 5 is what all that simplifies down to. So that comes to a single log of ln of x plus 4 times x minus 5 over x minus 1 squared. Since everything was expanded to start off with, let's expand this. X squared minus x minus 20 over x squared minus 2x plus 1. Some regular parentheses there. There we go. It's probably one of the harder problems in this set of exercises. Could you have done it where you just did it with multiplication, division, and then factored and did your cancellation? Absolutely. You can do that. If that is what you prefer, you absolutely can do it that way. Oops, let me go back and write down my answer. Then of x squared minus x minus 20 over x squared minus 2x plus 1. There we go. Clear the canvas here. And got one more here. 72 log base 9 of the 9th root of x plus log base 9 of 72x to the 6th minus log base 9 of 72. This is going to be log base 9 of x to the 72 divided by 9 plus log base 9 of 72 plus log base 9 of x to the 6th minus log base 9 of 72. That's going to go away. 72 divided by 9 is going to become an 8. So this is log base 9 of x to the 8th plus log base 9 of x to the 6th be log base 9 of x to the 8th times x to the 6th is log base 9 of x to the 14th. There we go. I believe that that is it for our discussion of logarithms right now. So come back and talk about something else next time.